Hi everyone, today's lesson is on solving trigonometric equations, and this first lesson is just looking at equation where sine x equals a. Okay, so first of all, this is the starter for this lesson, so I want you to sketch the graph of y equals sine x for the values of x from 0 to 360. Okay, so pause the video and have a go at that, press play when you're ready. Okay, so for this one, hopefully you remember from previous lessons what this sketch should look like. Okay, but if you don't, then we can work it out, no problem. Anyway, all right, so if we are saying sine x, all right, the values are from 0 to 360. So what that means is we're going to substitute, instead of x, we're going to substitute the values in intervals of 90. So we're going to substitute 0 first of all, okay, then 90, then 180, then 270, and then 360. Okay, and they will give us the y values. Okay, so in your calculators you just need to type in sine and then swap this x for 0, close the bracket, press equals. Okay, then do the same for the others as well. So sine 0 should give you 0 as an answer. Okay, sine 90 should be 1, sine 180 is 0, sine 270 is -1, and then sine 360 is 0 again. Okay, and then sketching the graph is just about plotting these points. So when x is 0, y is 0. Okay, when x is 90, y is 1, and then so on. Okay, so that's what it should look like then when you sketch it, and it's always going to be this same shape now. All right, and it's symmetrical then, about 0 and 180 and 180 and 360 and so on. Okay, so that's the sketch of the graph. And the more that we do these types of questions now, you'll easily be able to quickly just sketch that graph without putting the values into your calculator. Okay, so example number 1, I've just done the same sketch now on every page, but you can just re-sketch the graphs yourself. Okay, so example 1, press pause, copy this sketch down, and then press play when you're ready. All right, so it says find all solutions first of all. So that first of all identify that there's more than one solution. Okay, and it's saying when sine x equals 0.5. all right, so we are only looking for the values of x. All right, we're not looking for sine x. So think back to like trigonometry. If we were working out a missing angle using trig, we might get something that says I don't know, like sine theta equals 3/4. All right, and if we wanted to work out theta, the angle, we would do shift sine, wouldn't we? We would do the inverse of sine. So the first solution for this is just going to be by typing into your calculator sine to the -1 of 0.5. Okay, if you type that into your calculator, so shift sine 0.5, close the bracket, that gives you the first solution. Okay, so the first solution is 30 degrees. Okay, so on the graph then, okay, 30 degrees would roughly be there, wouldn't it? So that's the first solution. So what you've got to do then is from there, if we were to go up until you meet the curve, go across, and go back down, this would be the other solution. Okay, so that distance there is a gap of 30, isn't it? Because remember, this is 0. Okay, so from 0 to 30 is a gap of 30. This now is at 0 again, and y is at 0 again at this point. Okay, so that means that this gap here should also be a gap of 30. All right, so we are saying that one solution is x equals 30. We worked that out from the calculator. And another solution is this point on the graph here, look, okay, which obviously should be 150, shouldn't it? Yeah, because if that's 180 and this is a gap of 30, this value here is before 180. So 180 take away 30, okay? 180 minus 30 is 150. Okay, so the two solutions for that are x equals 30 and x equals 150. All right, and then there are no other solutions in this range because this line here, look, was continue across and it doesn't touch the curve at any other point. So they're the only two solutions. Okay, example 2, so copy the sketch down again. All right, so same sort of thing. We want x in that range and sine x is 0.2. So step 1, sine to the -1 of 0.2 into your calculators. Okay, so shift sine 0.2, close the bracket. This one comes out as a decimal, a little bit longer decimal. Okay, I'm just going to round it to, I'm just going to do 1 decimal place. Okay, so to 1 decimal place, that would be 11.5 degrees. Okay, so that's the first solution, 11.5, because that's in between 0 and 360, isn't it? 11.5 then on the graph would be somewhere there, wouldn't it? So we do the same thing. We go up to the curve, across, back down. That's where the next solution is. Okay, there's no solutions in this range over here then. So if that gap there from 0 to 11.5 is 11.5, then that gap there is 11.5 as well, meaning that is 180 minus 11.5. Okay, so because the sections are symmetrical, it's always the same distance in terms of the gap. Okay, so 180 minus 11.5 is 168.5, right? So that is the other solution. So the two solutions for that one is 11.5 and 168.5. Okay, moving on. So for this one, okay, still values of x between 0 and 360. This time sine x equals negative 0.1. So type into your calculators sine to the -1 of minus 0.1. Okay, so shift sine minus 0.1 equals, I'll do 1 decimal place again. So in this one, it comes up in my calculator as minus 5.7. Okay, so remember now that this point here is 0, isn't it? All right, so minus 5.7 is actually going to be this side somewhere, isn't it? So if I just pretend that this is carrying on over here, then minus 5.7 would be this side, wouldn't it? Okay, so minus 5.7 there. I'm still going to go down to the curve and then go across. I'm going to go all the way across this time. You could use a ruler though for this, so it would be more accurate. Okay, so going all the way across, it cuts the curve at 2 points. So it cuts it here and it cuts it here. Okay, obviously it cuts it here as well, look, but we're not going to use that value, okay, because the value of minus 5.7 doesn't fit into our range, does it? Okay, so we're just going to use this to figure out the other two values. So the only two values that we're going to use actually are these two, because these are the two in our range. Okay, so the gap from here to here, look, is 5.7, which means, okay, these two gaps are also 5.7. Yeah, so that gap there is 5.7, and this gap here is 5.7. Okay, so for this one, it's in front of the 180, yeah, so it's past the 180, and this was 180 plus 5.7, so 185.7. And this one, remember this part is 360, isn't it? So this is behind the 360 or before the 360, whatever. So it's 360 minus 5.7, okay, which is 354.3. Okay, so those are the two solutions this time. So x equals 185.7 degrees, x equals 354.3 degrees. Right, we don't include this one in our answer because it's not in the range that we need it. All right, and then last one. Okay, last example. So copy this down, press play when you're ready to go. All right, so values of x between there, sine x is minus 0.6. So sine to the -1 of minus 0.6 into your calculator. So shift sine minus 0.6 equals, okay, to 1 decimal place, I've got minus 36.7. So minus 36.7. Okay, 0.9 or 7. ignore me, minus 36.9. So same again, right? We know that this is 0 here, isn't it? So we're going to have to pretend that this carried on a little bit, right? And then minus 36.7, let's say is somewhere here. Minus 36.9, I don't know why I keep saying that. Okay, so down to here, and then we're going to go across again. Okay, so if I go all the way across, these are the 2 points where they cross each other, and that's there and there. So the gap here, look, is 36.9. So this gap is 36.9 as well. This gap is 36.9. So for this solution, 180 plus 36.9, okay, which is 216.9. And then this one is 360 take away 36.9, which is 323.1. So those are our two solutions. So right, x equals 216.9 degrees and x equals 323.1 degrees. Okay, this one doesn't count, remember, because it's not in this range, is it? All right, so on to the main task then. I want you to have a go at those ones. Okay, so pause the video, press play when you're ready for the answers. Okay, so welcome back. These are the solutions that you should have got. Okay, so double check any that you're unsure. Double check with the rounding. It just depends on how accurate you've been. Okay, yeah, and just for question 10, all right, what you would need to do for this one is divide by 50 first. So you should be doing sine x equals 25 over 50, all right, which is a half, isn't it? So basically sine to the minus 1 of 0.5 would give you those values. Right, second question then. So produce a sketch of the graph first, and then use the graph to solve the equation sine x is 0.7, but this time in the range up to 720. Okay, so this one is just going to be what we've done in all of the others. Okay, so the same sketch, and then the next one is a little bit harder. Okay, so you know what A looks like. I'm just going to do part B. Press play when you're ready for the answers. So for part B, okay, just going to make it a little bit longer, that's all. And this is 0, but we want to go up to 720 this time. Okay, so we're going 90, 180, 270, 360, 450, 540, and 630. Right, so the pattern will repeat itself. So it's going to go up, all right, back down to minus 1, up to 360. That's what we've been drawing already. And then the whole thing will repeat. So it's going to go back up here, back down here to there. Okay, so for x equals 0.7, we're going to do sine to the minus 1, 0.7 for our first solution. So shift sine 0.7, okay, is 44.4. Just checking on time a minute. Okay, so 44.4 would be here somewhere. So we're going to go up and all the way across, look. So the solutions are here, 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 and here. Right, so this one's 44.4. This one is 180 minus 44.4, which is 135.6. This one is 360 plus 44.4, so 404.4. This one is 540 minus 44.4,